In this video, I'm going to show you the excavation, footers, and the foundation work that it takes to build your own house. And if you're new to this channel, my name's Josh. This channel is all about DIY to save a ton of money. So be sure to subscribe, ring that bell so you get a notification every time I release a new video, and hammer that like button for me. That's all I ask in return for making this video. So we got a lot to go over today, so let's get started. While you're watching this video and all the videos in this series, I'd like to mention that this is how we build houses in our area, and how you would build your own house in your area may be totally different because of codes and different types of soil and whatnot. So you definitely need to make sure that you check your local building codes before building any structure on your property or any structure in general. This is what's called a rotary laser level. The excavator set this up and it corresponds with a receiver that's placed on a grade rod, and as somebody holds that, it'll beep to let you know when you're at the correct grade that you want. So as the excavator excavates, he's going to check off and on as he's going across the surface to make sure that we are about the correct grade. For this process here, it's okay to be within an inch or so, just because when you're using a loader of this magnitude, it's going to take out a lot of dirt, and also there's a lot of rock, so it's going to pull up certain areas more than others, but we're going to get this all leveled out first to have a nice pad to work off of. We're digging out for a basement here, and due to the lay of this lot, we don't have to take out a significant amount of dirt in order to do that, just because of the slope of the lot. And something to keep in mind, if this was going to be a really deep basement, let's say 8, 10, 12 feet deep here, the excavator would actually chip away part of the bank to reduce the risk of caving in. So that's something to keep in mind as well if you've never seen this done before. You will notice the excavator is making a pile of shale. That's because we're going to use the shale to help build the road and pad up around the foundation after the foundation's in. Because the foundation is going to be relatively high above the grade in some areas, we're going to build up the lot in order to compensate for that by the time the build is finished. When the excavator started, he stripped off the topsoil and kept that in a separate pile, and the topsoil is actually going to be used to place back around the foundation once the backfilling is done, and that's obviously for grass and whatnot in order to have a nice finished landscape. Here the loader is tracking back and forth across the pad. That heavy machine isn't just for moving dirt, it's also for compacting. The weight of the loader presses the soil down, squeezing out any air pockets. The compaction is critical before pouring any concrete on top of that pad. If the soil isn't compacted, it can settle over time and you'll have cracks in your basement slab. So it's important that you compact the soil on the pad if you're going to be having a basement. A crawl space isn't near as critical, but it's still important. Because we will be building the footers on top of the pad, we want to make sure that the parameter definitely has undisturbed native soil, meaning once the edges are dug down, we do not backfill across it. We want to make sure it is undisturbed soil. Now that we got the pad level, we're going to dig a trench to place our drain pipe that's going to go to our septic tank. We like to place that below the footer, so if we plumb in for a basement bathroom, there's going to be plenty of drop available to plumb the bathroom properly. Because you do not want to dig all of the soil out where the garage is going to be, because you want that filled, because there's going to be a concrete slab that's elevated higher than the basement slab. We need to make sure that we lay out the attached garage square with the house. Once we got the corner stakes for the attached garage in place, we're going to place a string line from stake to stake and use lime, or we can use inverted marking paint to paint the line onto the ground in order to dig out for the footers. We must jump up the garage footers. To do that, first we drive a grade pin into the house's footer area. That pin represents the depth of an 8-inch footer. From there we calculate in 8-inch increments because the height of a standard concrete block is 8 inches. We then must set the receiver on the grade rod accordingly. So if the garage footers needs to sit 32 inches higher than the house footers, we'd measure up in 8-inch increments to the grade pin. That way the block walls can be stacked up in clean full 8-inch courses to bring the garage foundation up to the correct height. By stepping up in 8-inch increments, everything lines up perfectly for the mason and you avoid having odd cuts or partial blocks later. Here the backhoe operator is referencing the line on the ground and digging the footers to the required depth and width. and the trench itself becomes the footer. The width of the bucket here is 24 inches. We could have used an 18-inch bucket with no problem, but it depends on your local building codes, and the load on a particular footer determines the footer width and thickness, and the depth of our footers must be at least 30 inches here to get below the frost line. I'm back here a few days later, and what we're going to do today is we're going to form up for our footers because we're going to do a block foundation. We priced a poured foundation, and it looks like it's about twice the cost of what's going to be to do a block foundation, and this is going to be for a basement. It was around $30,000 roughly to have this poured for a basement, but doing a block wall for a basement was about half that, around $15,000 for material and labor. So we opted to save the money. It's going to take a little more time, but it's going to be essential for doing the project on a budget. So if you look at what we got going on here, we need to find our corners and relay out for the foundation. And that's something that I did in my course. If you like, check that out. I'll put a link to my course in the description below where I walk you step by step where we went through and got the permits. We laid out the foundation and all that in the course. So we're going to plumb down from this area because this is going to be where we kept our stakes whenever we dug this out so we can find our corner again. So we're going to place a stake here to start our layout again, and we're going to place them around for the footers. To mark for the first corner, again, I'm going to reference the string lines from the stakes that we kept up after the excavation. So now I'm going to plumb down wherever they cross, and that's going to be our corner to start relaying out for the actual footers. All right, we got our corner to start laying out the foundation, so we're going to go ahead and square it up and lay it out. We have had a significant amount of rain in a very wet summer this year. That is why I'm wearing these rubber boots. Whenever laying out for the footers to be formed, we want to make sure that we take our time and try to get this as square as possible. Once we relay it out again after the footers are poured, that's when we have to make it pretty much perfect because that's going to be the exact corners. And because there are so many offsets with this house, it was a challenging task, but if you follow the proper technique, it can be done. Now that we have the house staked back out, we're going to form up the form boards in order to pour our footers. In our area, the code for the footers has to be 8 inches thick of concrete and 16 inches wide minimum. This is the corner where I'll be starting. I have a 14-foot wall going this way, and I have a 18-foot wall going this way. So mathematically, I'm just going to use a 16-footer to do a 14-foot wall. And then I got a 10-footer running this way, so we're going to overlap 2 boards ultimately to finish up this wall. So right here, we need 4 inches on this side of the corner. Then we need 12 inches on this side of the corner to give us 16, because right here is the exact corner where the block's going to be. So we're going to measure over 12 inches. So right here where I have these boards laying, we're 12 inches from it. And then this way we're 12 inches as well, roughly. You can always adjust these. And we're not going to be leveling these up. We're just going to put the forms to catch concrete, then the grade pins is what we'll level to. So as long as this holds the concrete, it's all we need to do. As long as it ain't lower than the grade pin, it'll do just fine. So we're going to screw these together first and use our deck screws. We're going to place just 2 or 3 screws to hold it together. All right, so let me double check, see if we're roughly where we need. That looks good. And this can be shifted down some. And that's close there. We now need to repeat that on the outside of the footer now. So we're going to do the same thing on this side. Other than using 12 inches, we're going to use 4 inches for our measurement. All right, we're now going to do the outside of the footer. Now with this, we need to take our tape measure and hook on the outside and get the exact length of our wall. We know that's a 14-foot wall, so we're going to hook at the end of this board, mark 14 feet. And it can be a little bigger, obviously, but we need a minimum of 16 inches. So 14 feet exactly should give us just that. We now need to place our form board here. So all we got to do is screw this one onto that layout, and that's going to be the start of this form board going this way. Now that that's screwed together, we need to make sure we get our 4 inches either way here in this case. So we're going to go ahead and slide this into place. All right, so we're now going to place a stake here to anchor this so it doesn't move. Now that we got this corner where we want it, We're going to drive a stake here, and I like to use the metal stakes that have the holes in them. You can place a nail or a screw and then remove it when you remove the stake. We're just going to drive this in tight and then place a screw to secure it. All right, that locks that corner in, and that's not going to move. Now we do the same to the inside corner. Since this corner is anchored, now all we have to do is measure 16 inches, and that's going to give us our exact width. And then we're going to place a stake here in this corner to hold the inside corner. Right there is 16 inches, and right here is 16 inches. I'm going to use a string line and hook to this peg that's marking our corner to the next corner, so we have a straight line to go off of to manipulate our form boards. I'm here in the other corner, and the same thing, I got to mark 14 foot here, connect this corner, and then measure to get our 4 inches off the string line down this whole form board on both sides. Now that we got this corner where it needs to be, we need to screw together where they lap. Here where they lap, we need to make sure that we are 4 inches away from the string line on this back side. And again, we need to make sure we're 12 inches and ultimately 16 inches total from form to form. And we want to try to level these up together just so it keeps the form consistent. All right, I got a flat rock. You could also use a 2x4 or something, but I just happen to have a rock here. So we're going to slide this under. You can see that helped get a little better there. Now we're going to place a few screws to hold this together. Make sure we have our 4 inches here from the string line. That looks pretty good there. I'm going to drive a stake to secure this joint together, just so it doesn't shift. And essentially the weight of the concrete is going to push against that stake, but I'm going to put a screw in it just to keep it complete. All right, and do the same to this joint. All right, make sure we have the correct width here. All right, that looks good. So now we're going to drive a stake here to hold this joint at the correct width. So now we got this back corner formed up. So we simply rinse and repeat that process around the whole footer foundation. Because I was away from this project and had to film another project, he went ahead and placed the grade pins around the footers and put the gravel in the foundation. And this is what's called clean, crush, and run. And that's what you want underneath a concrete slab because it's going to drain properly. And also I'm going to go in detail on how to place the grade pins around the footer because that's essential information. So in order to do that, you need what's called a builder's level. If you remember the rotary level that we used when we placed the grade pins when we were digging out for the foundation, that's essentially what this does, other than we had to level this up manually and we had to have somebody shoot through it like a scope as somebody marks it onto a measuring stick, and then that's how we're going to shoot our grade. So essentially same idea, other than it's more manual. So what we're going to do here is get our grade over to that pin that we used when we excavated in order to get the correct height for our footer. And again, we need an 8-inch deep footer. So that's essentially what we're going to do, is drive pins around. There's rebar that's 18 inches to get our 8-inch footer. Ignore the grade pins that are already in here. Those are going to stay there, but essentially I'm going to show you how to get to that point. So what we would do first is, here's the grade pin that the excavator put in. I didn't catch this till after I recorded this clip, but this grade pin is actually not the grade pin that we use for the actual grade. It's this one here inside of the form boards, just so you know, but it's the same idea. You would get the grade of your initial grade pin that's 8 inches and use that for all the grade pins around the footers that we have to use as our grade. So he's going to look through the builder's level, and I'm going to hold the measuring stick here. And actually this is just a piece of brick mold. You can use a 2x4, anything. You don't technically need a measurement per se. So he's going to scope through there, and then I'm going to mark exactly where his crosshairs hit on the board. And then that's going to be our grade that we use to place our pins. All right. All right, now we have it marked right here, and we've used this before, so there's other marks, but this is one we need. So I'm going to put a check mark beside it so we know that's our good mark. So now we're going to use that to place our first grade pin in each corner of the foundation. Grade pins go right in the middle of the footer, and what we use for grade pins is 1/2-inch rebar that's 18 inches long. So we get about 10 inches into the ground, which is plenty to secure it. And the idea is that's going to be the top of our concrete once we're to grade. So what we need to do is use a sledgehammer. This happens to be a 4-pound sledgehammer. We're going to start right in the middle of the footer and drive it down. And once we get to a rough idea about the grade, we don't want to drive it too deep. We're going to check it with the builder's level and then drive it exactly where we need it. All right, so now we're going to use our measuring stick, and he's going to shoot through the builder's level at the mark we made on this stick to see what we need to drive it down to, how much more. All right, how's that looking? All right, he's saying I need to go down about 1.5 inches, so that gives me an idea of how far to drive it yet. You don't want to overdrive this because you'll have to pull it back up because it will not have a strong base. All right, go down 1/4 inch yet. All right, he said that's good. So the great thing about a rotary level is that you can do it independently. You wouldn't have to have somebody shoot with the builder's level, and it obviously would beep, and you can hold it about where you need it. So it's much quicker and easier, and in fact it's probably better, but this works fine for us. So now that we got a grade pin in and you get the idea, what you'd want to do is place a grade pin at each corner of the foundation, and then just pull a string line if the wall isn't really long. I wouldn't pull a string line any further than about 16 feet. And again, it's not going to be perfect with the string line, but it'll give you a good idea. So you'd pull it tight and then just drive your peg down to where it's flush with that string line. So that way you wouldn't have to use the builder's level in order to get every pin, which is going to be much quicker if you use the string line. To give you an idea how I would quickly drive the rebar in the middle of the wall, like I explained, would be I would first come down here. We would drive this grade pin to the grade that we want. And then we would come over here to this corner. We would drive this grade pin down to the grade we want. And then we'd pull a string line from the top of that pin to the top of this pin, then drive all these center pins every 4 foot apart to the grade of that string line, and that's going to give us a quick way instead of shooting grade on each pin. So you can see an example. He's going to hold on top of that grade pin with that side of the string line, then I'm going to hold right on top of this grade pin, and you'll see the center ones are on top or right below the surface of that string line. So after we pour the concrete from pin to pin, that is going to be the correct depth. We got our 8 inches. Now that we have the outside wall footers done, we need to think about any footer that's going to go in the center of the house. Because this basement is going to have a beam going right down the center of this longest part, we need to place lolly columns that's going to hold up the beam, that's going to hold the floor joists. Now, if we were using floor truss, we wouldn't have to have a beam here if it's spec'd out correctly. You can avoid placing a beam and columns and all this. So long story short, we need to place what are called piers. That's what's going to hold the lolly columns, and that's going to support the beam. Ultimately, we're going to build a square box that's 2 foot by 2 foot and going to have an 8-inch deep footer by the time it's said and done. And in fact, it's probably going to be a little deeper here because we're going to remove a lot of this gravel where they're setting. So we're going to place a string line that's offset 1 foot from the center so we can use that to square up the pier boxes that we're going to build. Here's the wall we need to find the center of for our piers. I'm going to pull off the edge of this back corner. 12 foot 5.5 inches is the exact center, which is right here. So we're going to come over to 11 foot 5.5 inches and make a mark. And that's going to be where we place a screw or nail to hold our string line. Then we're going to do the same on the other side and run our string line across this area of the house. And the reason why this doesn't look center of this wall is because that measurement is off this area and then this section that goes around like that. So it looks like I'm way off center here, but it's center of the section that cuts back towards the garage. Because the beam we're going to be using here is going to be a 3-ply of 2x10s, and with that we can put lolly columns at a maximum distance of 8 feet apart for the specs of this house. Now we could get LVL beams and have our spacing way different depending on the engineering, but because we're using a 3-ply 2x10s, 8 feet's maximum. So we're going to use 100-foot tape. We're going to hook right beside this string line, and we're going to mark our 8 foot apart spacing for the piers. I'm just going to use rebar and place it beside where we need to dig out for the pier before we place our boxes there. So this is going to act as a temporary marker. All right, our very last one has about 7 foot between that and the wall. Right here where the center of the pier is going to be, we need to make sure we take out enough gravel to sit our form there, because if we don't do that, we won't have our 8-inch deep footer like we need. So we're going to use our boxes we made out 2x8s and figure right here where we need to take out the gravel. In order to form the pier footers, sometimes called pier pads, we're just going to use reclaimed 2x8s, and we're going to nail them together to give us a 24 by 24 inch inside measurement of the pier forms. So essentially we just cut two 24-inch long 2x8s and then two 27-inch long 2x8s and nailed them together to create a square form. All right, now we're going to place our form in here, and we're going to line up with our string line. We want to center up with that peg or stake. All right, now that we have our form set, we can place the gravel around the sides to hold it into place. Technically, you do want to level up these forms. The reason why is, yes, we're going to put the concrete in here and let it level itself, but because we need to make sure we have 8 inches thick of concrete, it's not a bad idea to place this level. So you can see we can shift that up a little bit, and that looks good there. And this way, that looks good where it's at. So what you need to do now is place stakes to hold that level. Now that we got all the form boards for the piers in, we're going to drive grade pins to match the same grade pins that are in the footers around the foundation. So that way, after you have everything poured, they'll be on the same level plane. And the lolly columns do have adjustments on them, but you don't want to have to adjust them 2 inches or something bizarre. And you're going to be pouring this basement, so you don't want the concrete to be real shallow around these either. So you want to make sure they're at the proper depth. So we're going to go ahead and drive our grade pins in the center of each one of these forms. Here where the garage intersects into the house's foundation, we need to place what's called a bulkhead. What that's going to do is give a place for the concrete to stop whenever we pour it, so that way it doesn't go down over the bank here. So you definitely need to do this. So check your local building codes to see what specs you need here. But for us, all we have to do is dig this down on the side of the bank, and then that's going to block this off. So I'm going to dig out into the bank here and slide this 2x10 down and get it level with the grade pin behind me. So whenever we're pouring the concrete, we can just run it flush to the top of that board. All right, now we're going to place a level here. I'm going to level off this grade pin. The bulkhead is now in, and we have it leveled to this pin, and we're sitting level this way. So now when the concrete pours, it's going to go flush like I mentioned, but I'm going to add the dirt that we dug out on the back side here. Okay, we have the bulkhead in now. It's very solid, and that's all there is to blocking that off. And if you're wondering how this actually works, once the block layer comes in and starts laying blocks, he's going to lay this wall first and place what's called a lintel. So it's going to lay here, and it's almost like a small header. It's concrete with a piece of metal in the center to act as a header like I just mentioned. So it's going to sit here and support any block that's going to go on top of it. And that's going to be how we tie in this wall to this wall. Now that we got all the footers formed up and dug out for the garage, we're going to go through and lay 20-foot sticks of 1/2-inch rebar on each side of the grade pins. I'm now going to separate the rebar into 2 different runs, one on one side of the grade pin and one on the other. Now that the rebar is laying where we need it, I'm going to grab the rod chairs and start in the corner and drop one off here, and then I'm going to drop one off every other grade pin. So it ends up being about every 6 foot apart. And I'm now going to take the rebar and place on top of the rod chair like this, and then keep that pattern up going down the whole footer. I cut 6 to 8 inch pieces of tie wire in order to tie the rebar to each one of those rod chairs. All right, in order to secure the rod chair to the rebar, we just simply take the tie wire and tie it together like so. Not very complicated. Do it by hand first, and then after you do it by hand, all we have to do is take our pliers here, and these are similar, these are just linemen's used for electrical. I just use these personally. They're just going to give it a nice twist. Not too tight, it will break the tie wire, but you want to tighten it down pretty snug though so it doesn't go anywhere, like so. And then I always just bend those over so they're not sticking up. And that's all there is to securing the rebar to the rod chair. Now when I get to an area like this where they overlap, I first take a piece of tie wire and tie the very ends like so, and then I'll come back on the other end and do the same, so that way they're bonded pretty darn good. And then tie it to the rod chair, and that's all there is to it. And then make sure you tighten them down using your linemen's. That looks really good, and we're ready for concrete in this section. I'm now here at a corner, and I'm going to show you how to do a corner. So I'm going to measure back to that rebar about 3 or 4 inches past the end of it, and I got about 6 foot, 6.5 to one side, 6 foot to the other. And what I'm going to do is measure the rebar and put a mark. I'm going to bend it so it curves around this corner. All right, so I'm going to pull this rebar out and make my mark at 6 foot. I'm going to be using a red crayon so I can see my mark. And right there looks good. So right there needs to be the inside of the bend. And this one's going to be 6.5. And now I'm going to take this galvanized pipe, and you can use a black iron pipe, anything solid, and I'm going to slide it over this rebar like so, up to that red mark, or close to it, right here. And now I'm going to bend it up. And as you can see, that gives us a nice 90-degree bend to go around that corner, and I'm going to do the same to the other one. Now we'll place these back in the footer. All right, so this is my longer one. So I know this is my outside corner. So it's going to be right like that. And then my other one is going to be my inside bend. And it's going to lay right beside it. All right, now we tie it together just like we did the other rod chairs. Now I'm going to tie it together right here where they overlap, and then continue that right here at the corner and then run it out. All right, as you can see, we got all the rebar in the footers and we are ready for some concrete. And just to reiterate, we're going to have 8 inches of concrete to fill this up. Here the ready mix truck is dumping the concrete into the hopper of the pump. This mix is a 3500 psi with a 5-inch slump. It's wet enough to pump smoothly, but yet still strong once it sets. This Reed B50 HP pump uses hydraulics to push the concrete through the cylinders and into the pipeline. It's the most effective way to move a lot of material quickly, especially when you've got long runs and hard to reach areas. From here, the concrete flows through the hose right to the worker, placing it into the footers and forms. We had to use this pump because we could not get the concrete truck close enough to be able to pour the footers manually. Here the pump is sending the concrete into the footers at the garage bulkhead, which is the section that we formed earlier. The hose lets the worker place the concrete exactly where it is needed, filling the forms quickly and evenly. We then followed behind with a concrete placer or rake where we leveled the concrete to the top of the grade pins, and here we are filling to the other bulkhead on the other side of the garage footers before dropping down into the primary footing of the house. Here you can see the wireless remote used to control the pump as the operator is pumping the concrete. Using the same method, we are now pouring the concrete in the forms that are for the house footers. If you're curious on the additional cost to have a pump on site and the concrete formulated for it, it was about $600 for the pump itself to be on site and have somebody operate it, and it was also about $600 additional charge to have the concrete mix formulated so it will go through a pump. After the first load of concrete, the second load is now being dumped into the hopper, and it does have to flow at about the same rate the operator is pumping the concrete. And I must say, it is significantly easier to have a pump on site pumping the concrete than it is to wheelbarrow around the footers. And you can see after everything is poured, it is now setting up. And I would like for you to take note of the texture that we like to leave using the rake. That's going to help secure the block because it's going to be a rough surface. We do not smooth out our footers because we want to make sure it's textured so that the mortar can grip onto the footings. There are a few ways to tie the block walls into the footers. Some builders set vertical rebar in the footers before they pour. Others drill epoxy after or drop bars into the cell blocks before grouting. Local codes and inspectors usually decide which method is required, but they all serve as the same purpose, tying the wall securely to the foundation. In our case, we always let the mason handle that part of the job. Before pouring footers, I'd recommend that you consult with your mason to see what they want you to do. Add the vertical rebar now or they'll take care of it later. I'm back here the next day. He stayed into the evening after we poured this concrete and removed the form boards. As you can see, it looks really good, and it's important to do that as far as removing the form boards as soon as possible so that way they come off easier. If you wait for the concrete to really cure, it's going to be stuck to those boards much better. So I highly recommend removing your form boards as soon as possible. Now we need to lay out the house again onto the footings. Now that the footers are poured, the next step is laying out the house directly on top of them. This is where I transfer the plans into real-world measurements, and I start by using blocks to mark the corners so that I have a solid reference point before pulling the lines. This process has to be accurate because every wall in the house will sit right on these marks essentially. If you'd like a deeper dive, I share a step-by-step exactly how I laid out the footers initially in my course. If you'd like to check out that course or the course membership, I'll put a link to it in the description below. Here I am using a construction crayon to mark right on top of the footers, following the string line to get precise measurements and marking each corner to show where the walls will line up at. The last step is pulling diagonal measurements, and by measuring from corner to corner both ways, we can confirm the layout is perfectly square. If the diagonals don't match, that means something's off and we will adjust it accordingly. Getting this square now ensures that the entire house will frame out correctly. When the house footers step up to meet the garage footers, we need a way to accurately transfer the elevations and locate the corners of the garage. The easiest DIY method is to stack concrete blocks up as a column right on top of the house footers, building it up to the exact height of the first course of the elevated garage footers, and once the column is plumb straight, we can run a string line from one column to the next. That line gives us a perfectly straight reference when laying out the garage foundation. From there, we measure off the column to locate the garage corners. By working off that straight line, it's simple to get accurate marks and keeping everything square. This approach works really well whenever jumping up because it ties the higher elevation of the garage back to the baseline of the house. It doesn't require any special tools, just blocks, a string line, level, and a good eye for measurements. It's a straightforward method that anyone can use to get great results when marking out for elevated footers. Now that we got 3 of the 4 corners marked, it's as simple as pulling the measurements and intersecting them both ways by measuring off each of those corners. By measuring off each of those corners, we can quickly locate the last corner of the garage, making sure the whole layout ties in square and accurately. Here is an excellent visual how when you eyeball across the columns, we come here to the corner, and now that we have all the corners marked, we're going to use a hammer drill and drill down into that exact corner, and then we're going to place a nail or a screw to mark that so that there's a hard mark at each corner so that there is no discrepancy. And these are the corner marks that the mason is actually going to use to lay his blocks, so they are critical that they are accurate. Now that we have completed the layout for the foundation onto the footers, we had the blocks delivered, and believe it or not, the best deal we found on blocks was from Lowe's, and I'll put a link to these blocks in the description below. But most of these are 8-inch cinder blocks, and these are going to be fine for what we're doing here. This is a great visual how the mason used our corners to lay the blocks. Now that the block foundation is laid, we need to transition to wood, and in order to do that, we're going to install what are called sill plates. These are pressure treated 2x8s, and it's going to cap off the block wall, and it's also going to be anchored down using what are called anchor bolts. The anchor bolts are embedded into the foundation, and the mason installed them within 6 to 12 inches from each end of the board and about 4 to 6 feet apart. And I'll also show you strapping here in a bit. Before setting the sill plates, we need to install what's called bug guard, or some people call it sill sealer. And this is going to seal between the plate and the block wall or the poured foundation, whichever one you go with. And this is going to help prevent air from penetrating between the board and the block wall. And it's also going to help keep insects out from entering into your building. So we have that laid down first. Now we're going to cut this sill plate to length. I first cut and installed the first 2 sill plates on the garage wall that has the header, and that's going to give me an area to butt my tape measure up against to get the measurement for this sill plate. Because there's going to be a door here, we figured we'd save on material and go ahead and compensate for it. So we're going to measure 38 inches and make a mark. I'm now going to measure up to that mark. We're going to cut this 94 3/4 inch. All right, we're just going to measure this to length and cut it using a circular saw and a speed square to get our straight line. We now need to mark the bolts so we can drill out for them. So we're going to set this up into place and do that. All right, in order to mark where to drill out for the anchor bolts, there's a couple different ways we can do this. We can line it up with the edge of the wall where we need it installed, then take our hammer, and that's going to make an indentation wherever the bolt is that needs drilled out, or we can lay it right up here against the bolt and tight up against that plate, and we can mark exactly where it's going to hit here, and then we can measure over to see exactly where we need to drill it out. So if we mark that, we can measure off the edge of the wall, and that tells us we need to come over 4 inches to the center. So we're going to go ahead and mark this and then drill it out. Here's our mark right here. Now if we take our speed square off the edge, we can mark over here and get our 4 inches. So we know we need to drill that out right there. I got a 3/4 inch paddle bit here. I like to oversize the hole a little bit because sometimes the anchor bolts aren't perfectly straight up. So this gives you a little room to play. All right, now we drill each hole out like that for the anchor bolts. Now that we got the sill plate drilled out for the anchor bolts, we're going to place it right over the anchor bolts. And you can see we're nice and flush with the outside of the foundation. And now we need to place our galvanized washer and 3/4 inch galvanized nut to secure it to the foundation. Simply place our washer, the nut, and I'm going to use my impact driver with a 3/4 inch deep socket and tighten that up. And that is snug. Now we repeat that on the rest of the bolts. This is the foundation anchor strap before it's installed. This is the base that goes down into the sill of the block wall, and this part folds and it'll bend out and up even, and that will go down into the sill, and that creates kind of a wedge so it does not get pulled up. And then the top part is what folds out over or underneath of the sill plate and then folds over it in order to anchor the sill plate to the foundation. These just fold up around the sill plate. Some people call them sill plate anchor straps, so either term's fine. All we have to do is take a hammer and bend this right up around, and we're going to use these joist hanger nails. These are more or less just metal strap nails, and they're going to nail into the holes to hold the sill plate down. We usually always use anchor bolts, but I wanted to have these here to show you there's that option as well. I'll bend it up and place the nail on the side. We're going to bend it down, place a couple more, and do the other side. And that's all there is to doing those. Those are much easier than the anchor bolts, but we prefer the anchor bolts. So I'm going to do that for the rest of the straps. We need to seal around the bottom part of the foundation where the dirt's going to go against the block. We must apply what's called foundation coating. This is more or less a tar that seals that outside of the block that has the parging on it, and that's going to help from the water penetrating through the block. And yes, it will not keep out all the moisture, I understand that, but it'll definitely cut down on it significantly. And you can also have this sprayed on, but it's much easier as a DIY option to use either a brush or a roller. We typically just roll the walls, and we actually got, this is kind of a broom really, and we're going to use this to dip down to the bucket to get a real thick amount around the base, because that's where most of the water is going to lay, right around that footer. So we like to have it super thick there. Then we roll the walls using just a standard roller. And you want to use an extension handle if you can, because it will make it easier. But before we even apply that, we're going to chalk lines around the foundation for our grade, just so we don't go above it, because once that hits the block wall, if you ever do put stone veneer on, this will stop the stone veneer from adhering to the wall. So you don't want to put it up too high to risk that issue. And also cosmetically, it doesn't look that good. The standard parging on the wall looks better than having the foundation coating up to your siding. The cool thing about this brand is that it's actually water-based, meaning if you get it on you, you can actually clean up with water, believe it or not. But you still want to use mineral spirits or something of that nature if you really want to clean it up well. But because it's water-based, it's definitely a little safer to use per se. But you want to make sure you wear eye protection of some kind, gloves, and that type of thing to protect your skin. So we're going to chalk the grade around the foundation and start applying. To apply the foundation coating, I have an extension pole onto the roller like I mentioned, and I have the bucket here, and all I have to do is simply dab my roller in the bucket, and then we're just going to roll it on like you're rolling paint onto a wall. And we don't want to go above our chalk line because, like I said, that's our grade. So we're going to roll this on really liberal. If this first coat takes up a lot, the second coat goes on really quick because it's already sealed. So don't be afraid to really put it on here. So we're going to go ahead and start. And we already stirred this up really well. So you can see this stuff really soaks it up onto that parging. So don't be afraid to put a substantial amount on to really coat this area. And don't be afraid to get a little messy with this stuff because there's almost no way around it. So this is a time you want to use old clothes or wear a bunny suit or something, because you're definitely going to get some on you at some point. And that's where the extension pole keeps this really easy to get along this bottom, pretty heavy. But we're going to use the brush here in a moment to really hit that bottom well. All right, so that's the gist of putting it onto the wall. Now we're going to switch over to that broom slash brush that I was showing you earlier. Now with this, we're simply going to dip it into the foundation coating and then really slop it thick here down around the bottom where the water has a chance to lay. So we want to make sure it's sealed really well. Nice thick coating. And that, my friends, is what you want to keep that moisture down on the inside. All right, nice and thick there on the base, but you literally rinse and repeat that around the whole foundation. After the first coat's on, hit it one more time, then you're done with your foundation coating. The last thing I'd like to show you about this foundation, because it's going to be a basement, we had to install what's called a French drain. We would not have to install this if it was going to be a crawl space per coat in my area. So all we had to do was put a 4-inch corrugated pipe in, and it's perforated so water can drain out. It goes around the whole foundation, around the footer. Then we place gravel around it, and it kind of holds it into place and gives us a place for water to drain through as well. Then we have to put down some kind of fabric, and this fabric stops any sediment from going down and clogging up the pipe. And then on top of the fabric's a little more gravel to hold it into place, and then we'll backfill right up against that, and then we'll daylight this out once we get to this part of backfilling. So right now we just stopped it right here so I could show you. If you're wondering why you need a French drain, the French drain is going to help facilitate the removal of water out from around your foundation, so it's very important to have one. Towards the beginning of this video, I showed digging the trench for the 3-inch pipe that's going to be underneath of the footer. Then shortly after we exited the house, we converted the 3-inch pipe to a 4-inch pipe. Then from there we'll go straight to the septic tank. Here is the finished basement block foundation. We have 10 courses of blocks, and because we formed our footers on top of the pad instead of digging out for them, that gives us a total of 88 inches. Then after we put the gravel in, and then we're going to pour the concrete, that will give us around 80 inches of finished height, which is going to be comfortable for most people, but that would be considered a low basement. If you want a taller basement, I would recommend at least 2 more courses of block. If you'd like to see how we're going to install our lolly columns, the beam, the floor joists, and the subfloor, check out this video. It'll help you out.